Get our cameras going, everybody. I want to open up the chat. I'm going to throw this out here just to start the day. There you go. That gives you something to put in the chat. 1, 2, 3, or 4. How do you feel today? Pick a pumpkin. Daniel feels like a 1 and a 4 combined, apparently. Or a 2 and a 3. I don't know. I'm just trying to do the math. All right. 1s, a 2. I guess I would kind of feel like a 2. I feel like I'm trying to knock the fog off this morning. It just seems like, oh, it's cold out there, and I'm just like, I don't know. I feel like there's a fog around my brain, not thinking straight yet this morning. But we'll get there. All right. Well, let's look at our lesson this week since we're here and ready to roll. Foundations of Programming. See if we can't get everybody to be a number 4 pumpkin. All right. So looking at our grade screen. Let's see. This is the week of Halloween. What's due November 5th? That's next Sunday. Wow. See, we're almost to November. Next time this class meets, it'll be November. 2.04, the software development lifecycle. So you had the math module. If you haven't got that turned in, you need to get it turned in right away because we have another thing next week that's a program, the Module 2 project. We do not have a test at the end of this unit. We have a project, which is a program. So don't get way behind on these programs, guys. Those of you that haven't got the math module turned in, loop, 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 alert, alert, get that turned in. If you need help with it, get with me, right? You can stay after class. You can come Wednesday. Oh, this week is a B day. I'm going to change my sign over here. B day. We've had 2 A days in a row. We don't get another one. B day Friday. But let's look at the software development lifecycle. Okay, the programming process. See, the thing about writing great programs is the writing part really is only one step. That's one step in the process. There is a methodical approach, and all programmers grow to learn to love, love to hate. Okay, it's just something else here. Programmers work to create and solve all kinds of problems. I mean, there are programs used. You use computers in all kinds of things in life now. So what they do is different, but how they do it is steadfast. You know, the saying, there's a method to the madness. Well, here's the method. So after this lesson, you'll be able to understand the steps, documentation, and tools used in a standard software development lifecycle. We call it the SDLC. So we'll give it an abbreviation, so we don't have to say software development lifecycle every time. The SDLC. And we're going to learn to select the appropriate model to use in software development projects, recognize the tasks performed and the tools used by programmers to release software updates, because you have lots of software that you get updates on all the time, including Buzz. Buzz will say you have a new version available. Understand the need for ongoing program maintenance and methods used to facilitate changes and version control. So let's look at what it's talking about. All right, so as you've already realized, programming can get pretty complicated. I mean, the math module was a bit more complicated than the programs we've written before, and it's going to grow throughout the semester. So I love this little picture here. Code doesn't work. I have no idea why it doesn't work. The code works. I don't know why this works. That's a common expression for programmers on both sides. So programmers call their plan the software development lifecycle. This is also sometimes called the application development lifecycle or the software development process. So this is basically the fully planned out life of a project, from the early ideas where we're saying we need a program to solve this problem. Well, what's the problem? This. Okay, well, what can we do with a program? Yes, the early ideas and planning to the execution and delivery. So without an SDLC, the programmers can get stuck wondering why things aren't working. So remember, it's always smart to have a plan. That's why we've added that pseudocode to our programming now. So here's the steps. So a software development lifecycle, an SDLC, generally has 5 steps. So we're going to take a look at each one and see how they help programmers do their job. So this applies to software. But for this explanation, we're going to use bicycles. All right, so the software development lifecycle explained with bicycles. Okay, number one, planning and analysis. So this is the first step. This is where you define your project goal, create a requirements document, which generally we've done with the template. It's what's required, and analyze the scope of the work. So with a bicycle, figure out what a bike needs to work. It needs wheels, it needs handles, it needs a seat, it needs some gears. If it's a multiple speed bicycle, it even needs gears if it's just a one speed, it just has one gear. Find out where you can buy the parts, how long it's going to take, who's going to build it, where you'll sell it. See, that's using a bicycle. This is the same thing. All right, the next thing is design your program by writing the pseudocode. All right, that's just your basic written plan of your program and kind of mocking up how the software will work, what it will look like. So with bicycles, the design is you kind of sketch out your bike design. Oh, I'm going to do two wheels. I'm going to have these manual pedals. I got some handlebars. I'm going to put a bell in a storage basket to make my bicycle more functional. Okay, number three, coding. This is where you actually write the code or build the bicycle. You've gathered all your parts. You've got your sketch, your plan. Build it. Number four, testing. This step includes identifying defects and debugging. That's when you run your program and see, does the program do what it's supposed to do? Make sure your software is running in tip-top shape. No errors. Yes, it actually works. In this case, you see if the bicycle actually works. You do some pedaling slowly, see if the wheels turn. You pedal fast to make sure the chain doesn't come off. You make a U-turn, you try out the brakes, you make sure the seat is comfy. Don't forget to test the little bell. Ding, 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 ding. Test the bell, see if it actually works. And then step five is maintenance. And we haven't really done this with our programs because we haven't put them out into the world for users to use. But this primarily involves updating and making improvements based on user feedback, as well as resolving any defects that arise. So when you put a program out there, you'll get feedback from users and say, hey, this would be a lot more useful if it would do this. Or is there any way the program can do that? And then you can make those updates and improvements. With bicycle, your test users have mentioned that the gears are a little sticky and the brakes are not always reliable. Those are big problems. So tweak your design for a smoother ride, update your user manuals as needed. So there is the SDLC explained with bicycles. All right, let's look below here. Here's where we're going to learn more about it. So planning and analysis. The planning and analysis step kicks off every SDLC. So the team defines the project goals, creates a requirements document that outlines what do we need to build the software. That analysis includes looking into the budgets, because the more time you put in it, the more costly the program is. How many people are going to need to write this big program? You're going to have a timeline, how long it's going to take, because the boss always wants to know that. What resources you have and what resources you need. And what is the existing technology? What parts can we steal that we already exist out there? We won't have to create, right? In other words, plan before you do. You don't just jump in and start writing the program. You got to figure out all the parameters that you need. So this saves tons of time, prevents wasted effort. I mean, you can jump in there and start the program. It's just going to take you a lot longer, and you're going to go back and fix things because, I didn't think about the fact that I need to do this. I planned it ahead of time and might have. Let's look at design. So rather than jump right into writing your code, programmers use these steps to write their pseudocode. Right? That's where we kind of do a mock program, a fake program. So this helps them think through the entire process, make sure their logic is sound. It's also where they provide mock-ups of what the software is going to look like. Well, it's going to kind of look like this. They may draw an output screen, how it should work. And they record everything in the program design document. Program design document. That's for everyone on the project to look at and kind of keep track of, for future reference. All right, look at coding. This is where the magic happens. This is where the programmers actually write the code for the program. Once design documents are received, everybody gets their design documents. Everybody's on the team. Programmer breaks the work up into chunks and begins writing the program. Okay, I'll write the part with the input statements up here. Hey, Bob, you work on the printing, the output, what it's going to look like. Sally, I need you to do all the stuff where it's going to calculate all of this. And so they may break it up because a lot of times programs are very, very large. And so they may break up the chunks and then piece them together at the end. So they break the work up and begin writing the program. And as the programmer writes the code, he or she includes comments to explain the purpose of each part. So as you're writing this, you put those little hashtags. This is where it calculates the total cost. And then have those lines of code underneath that. And then another hashtag. This is where we print this. Just so, especially since it's the team of people, if I go to look at your code and trying to figure out how my code needs to fit in it with it, having those little hashtags in there with those comments helps me to figure out what each section of your code does. So you can use all the hashtags you want to in a program to explain steps. It's very useful. Step 4, testing. Did we mention the testing plan? Yeah, there's a testing plan. This document what and when. This documents what and when something was tested. Okay, I tested Sally's code on the calculations. It appears to work correctly. Or it didn't work, how it was resolved. I had to change line 38. Had to add this equals in there. And who tested it? Mr. Brock tested it. Testing promptly exterminates all identifiable bugs. Now, not all bugs are identifiable right off the top. Sometimes you get farther in before you figure out something's not working. During this step, programmers report all bugs pronto. Oh, hey, Chuck, your line 38 is giving trouble. Can you look at that? And fix it to make sure the software runs as expected. Right. So get all the pieces working correctly. And then finally, maintenance. So this stage is what makes this process truly a cycle. Because if something needs tweaked once the program's out there and people are using it, we got to go back to our planning analysis and say, okay, how can we correct this function? How can we add this function? How can we make this more useful? So it will cycle back through the same thing again. It involves continued code maintenance, checking for missed bugs, because maybe you don't realize something was working until somebody enters something you didn't expect. Oh, with that input line, they actually entered a decimal number. I thought it was always going to be integers. Now it's a bug. It worked properly as long as I was entering integers. So code maintenance, making design and functionality improvements based on user feedback, implementation of new requirements. Oh, now we need the program to do this because the company's changing our policy. We're going to do this. So now it's something new we need to do. And then, of course, user support. Hey, I tried doing this and did this. And then it's not designed for that. Here's what you need to do. And the team will document all their maintenance related work. So they keep a record. Here's what we've changed. Here's what we've done to it. Here's what we've added. Here's what someone requested to ensure the software is operating at optimum levels. All right, so that's kind of a good overview of the software development lifecycle. All right, let's look at our next page. All right, when two people say they love music, they can mean totally different things, all right? If I say I love music, you say you love music, there's a good chance we're not talking about the same music. One could be a die-hard hip-hop fan, while the other is obsessed with that YouTube heartthrob turned cheesy pop icon. You know who I'm talking about. These artists do things differently in their live performances, but they both get the job done. They make their fans happy. Well, software development life cycles also use different methods to get the job done. Two of the most common methods are known as the waterfall method and the agile method. For some projects and people, one might work better than the other. You just have to understand how they work and which one to pick. So let's take a look at the differences and similarities of these two methods. So in the waterfall method, with the programming task details, project teams work on one step at a time. All right, let's work on this step here. We're inputting data into the program. And teams do not move to the next step until the previous step is completed, approved. Okay, everyone, it just works. We've tested it. Everything's great. That works. Now let's move on to calculations. Extensive documentation is required to keep everybody on track. Right? This allows the team to keep control over what version of the project we're working on, what changes are needed, what step of the SDLC they're in. The benefits. process is very clear from beginning to end because you start at the beginning, you get that working, you go to the next step, get that working, go to the next step, get it working, and it's a very clear process. The drawback is if a change is needed from a previous step, we get the third or fourth step and we realize we left something out of the first step that can really delay the whole project because now everybody's going to drop everything. We got to go back to that first step and we got to incorporate this because we didn't realize we needed to do that until we got to the third step. So let's compare that to the agile. Project teams do smaller portions of the entire project in small sprints. We'll break it up. Teams can interact to handle different steps simultaneously if needed. Hey, Chuck, I'm going to change this input. I'm going to add this here. So you need to change that in your print statements to make sure you include that because we're working on different steps of it. Documentation is still required to keep everybody on track. So this documentation allows teams to keep control over what version of the project you're working on and how the project has changed as we've gone. As an approach to rapid development, rapid development refers to an approach that puts a larger emphasis on the development than the planning, allows for the project to evolve and adapt as it's built. So rapid development, you do less planning and you develop it as you go along. So the focus is on development rather than planning, enabling teams to start working quickly. The process may become confusing at times, though, when people jump back and forth among the different steps because you're working on a lot of the program at the same time. So the type of methodology you choose depends on the type of project, as does the programming language. We're working with Python. There's a bunch of other languages out there. However, some languages lend themselves more readily to rapid development. For instance, certain programming languages like Python or Java have more robust libraries or tools that are already built into them. Like we've already pulled the math module tools. Other programs may not have those tools built in, and so you got to do more programming. Some languages allow you to easily reuse different parts of your code. You could copy this code and use it again down here very simply, making it ideal for rapid development. As you can reuse, software reuse can save a ton of time. I don't have to write this code again because it has to be different. I can use the exact same code over and over. While programming languages can aid in the rapid development, it's still dependent on completing all steps in the SDLC. Without proper planning or testing, you can rapidly develop a project, but it probably have more bugs. Less planning, less testing, you can have more errors. All right, let's look at the last page of the lesson here. When does it end? Well, it doesn't really. In programming, it doesn't. That's why it's called a cycle. The cycle, you just keep looping back, right? Programmers usually don't ditch projects as soon as they're out the door. All right, we've built Microsoft Windows. It's out there. We're done. Oh, no. No, Microsoft Windows has been around since the 90s. And how many different versions of Windows has there been? Oh, my goodness. I have no idea. Windows 95, Windows 98. There was Windows XP. There was, I don't even know what the current Windows version is. There's so many versions of Windows. And after they put it out, they're still sending all these updates and they're finding errors and they're finding bugs and they're finding vulnerabilities from hackers. And so once programmers release software to the public, their major focus is usually ongoing maintenance. And a lot of times working on a new version at the same time as they see improvements that can be made. Instead of just updating the current software, they may be working on a new version to replace the software. You ever seen a notification on your phone that there's an update available for one of your apps? One of the many examples of ongoing maintenance that programmers handle on a regular basis. If you play games on your phone, they're constantly developing new levels for your game a lot of times because you'll get updates and then there's new levels available. Why do they do this? Well, there's two reasons. Bugs, that's a big reason. It's actually not as common as you might think, unfortunately, but it does happen. And they got to be ready to correct the glitches that occur in their software. Having your favorite app crash on you at the crucial moment, that's the worst. So, yeah, a lot of times the early updates are a lot of times fixing bugs that have been identified. The other thing is enhancements, right? Enhancements. That's a lot of the updates you get on your games on your phone. This accounts for the largest portion of the maintenance work. It seems we're never happy with our software like it is. We always want it to be better. Like, okay, I'm playing this game and I've ran out of levels. Like I finished Candy Crush when I had leukemia. I was in the hospital and I finished it. And then every Wednesday they would put out 15 new levels. Every Wednesday. Now I've finally quit playing it a couple of years ago, so I don't know what level they're on now, but I was way up there in the thousands. And I would sit around and wait for Wednesday where I could get new levels. Now I do the same thing with what's the game of Homescapes. I finished that and I'm waiting on new levels, which come out on Thursdays. So we're never happy with our software as it is. We always want it to be better, and programmers have to come up with new ways to meet the demands. Yeah, have you ever thought, boy, this game would be perfect if only send a message to the programmer? They might actually do it. If you're playing the game, you might actually get your wish, because that's how they make enhancements a lot of times, off user feedback. Oh, here's a little trivia for us. How much was the most expensive bug? You got a dollar figure in your mind? The most expensive bug that's been identified. Let's take a look. $10 billion. Were you right? You probably guessed a little low. Think bugs are no big deal? Tell that to the northeastern United States. In 2003, there was a glitch that caused multiple power systems to overload data access and caused a total blackout. Which reminds me, I'm here on the BHS campus. I'm in the South building. The North building is having power problems this morning. My wife went to get in the building and her little key fob wasn't working. All the lights are flickering in the building. They're having a partial blackout in the North building here at BHS this morning. But for this, programmers had to sift through millions of lines of code to find the bug, and it cost them about $10 billion total to get this bug corrected, and downtime, what it cost being out of power and all that. So it can get pretty serious. Millions of lines of code. I hope they put lots of comments in there to help them know what each section did. So in other words, ongoing maintenance lets programmers update their software so users can continue to enjoy it for a long time. These updates may come through email. There may be push notifications, little pop-ups you get. Hey, this is available. Or it could just be a version upgrade. For the user, it's just as simple usually as just pressing an update button when the programmer sends a change. Some updates happen when you don't even know about it. In the background, while the computer device is running, it's updating stuff, not even asking you about. And for those, you may never even know it happened, but there's all kinds of updates on most of the software you use. So two major concerns of programmers in any SDLC are version control, keeping good organization throughout different versions, and change management, keeping documentation, keeping it a master file that documents all the changes that are needed and made. So version control is important because a program can go through many different iterations in its life cycle. When a game gets a new level, your social media app gets a better messaging capability, programmers got to keep track of both the old and the new versions, because not everybody updates. Not everybody updates at the same time. With this organization, it's easier to fix problems that might happen during updates. Change management means programmers are keeping strong notes about what changes are needed for the future. Hey, next time we do a big update, we need to add this. As well as what changes have already been implemented. This can be important when the team's reviewing what it needs to spend its time working on. So even though every good programming team has a plan that keeps these things in mind, it may not carry out plans the same way. There's many methods for implementing the SDLC, and teams have to choose the method that works best for them. So let's look at the assignment. Last page just says, hey, good job. You read this whole lesson. Now do the quiz. So let's look at the quiz that goes with this. This is not a program this week. 1, 2, 3, 4, 5 questions. The last one's true, false, it looks like. All right, 5 questions. Just a 5-question quiz this week. So if you have not written a program like last week that was due yesterday, or a previous week beyond that, this is a good week to do that, because you have just a 5-question quiz this week. So you don't have to spend a lot of time on this. Get those in. If you start getting behind stacking those programs up, you're going to feel a lot of like, oh my gosh, I'm never going to get all this written. Yeah, it's going to feel that way if you don't do it week by week. That's why we break these up. We're just one program a week, not even every week, because we're not doing one this week. If you need help with a program, you don't know what to do, you started on it, you're totally lost, that's what I'm here for. That's why I'm here to help you. If you're writing a program and you got all these errors, that's what I'm here for. I can help you debug programs. So I want you guys to feel successful. I want you to feel like you can do this. And also in those lessons, whenever there's a program, if you go back to that lesson, it has those little Python windows in there where it says, hey, try this. And you run their program they wrote and see how it works, because they give you wonderful examples of how these lines of code work and how these commands, what these commands do. So look at the right side. It tells you things to change in those programs. And it's a great example to help get you started on writing a program. So if you haven't done that, that may be why you're lost. So play with those. All right, guys, any questions? That's the whole lesson. So you guys can take your quiz now or whenever you want. You got till Sunday to get that done. But the main thing is, if you're behind on programs, please get those in ASAP. We're only going to have more as we go on. And Wednesday is November, which means we're running out of semester. So it's a B day. So Wednesday is the only other day we'll meet this week. Of course, if your grade's under 70%, you'll need to be here. If it's not, you can still come. Mr. Brock, I was trying to get this program in from last week, and I hear I'm lost. So I'm here. Great. Let's work on it. So that's all I got for you guys. Bundle up. It's cold, cold, cold out there. Better get your booties. Oh, all right, guys. Have a great week.